Hello grade 8 students. Today I will be discussing multiplication and division of rational algebraic expressions. So for today's learning target, I can simplify, multiply, and divide rational algebraic expressions. So let us first have multiplication of RAE. So what are the steps in multiplying rational algebraic expressions? So number one, write each numerator and denominator in factored form. So you have to recall factoring common monomial, factoring difference of two squares, sum and difference of two cubes, factoring quadratic trinomial, and factoring perfect square trinomial. After that, the next one is to cancel out common factor. And then, multiply the remaining factors. And lastly, simplify if possible. So don't forget to simplify your answer. So let's have our first example. So what is the product of 2x over 5 times 3x over 7? So as we multiply this one, look on the factors that we can cancel. But here, we don't have any numbers or variables that we can cancel. So therefore, in that case, we just simply multiply numerator to numerator and denominator to denominator. So 2x times 3x, the answer is 6x squared. And then 5 times 7, the answer is 35. And then as you can see, the GCF of 6 and 35 is 1. So therefore, this will be our final answer. Let us go now to the second example. So x plus 1 over 5 times 3 over x plus 1. So as you can see here, we can simply cancel the common factors, that is x plus 1 and x plus 1. So as we cancel the common factors, multiply the remaining factors. So again, as you cancel common factors, the answer there is 1. So 1 times 3, the answer will just be 3. And then 5 times 1, the answer is 5. So therefore, the final answer will be 3/5. Next, let us proceed to the third example. So we have here 2 over x plus 1 and x minus 3 over 3. So as we multiply these two expressions, as you can see, all of the terms here are non-factorable. Okay? And so therefore, we don't have also a common factor that can be cancelled out. So what are we going to do is to simply multiply numerator and to numerator and denominator to denominator. As you can see here, this one is a monomial and then we're going to multiply it to a binomial. So what are we going to do is to use distributive method. So 2 times x, the answer is 2x. And then 2 times negative 3, the answer is negative 6x. Over, that is distribute 3. So 3 times x, we have 3x. And then 3 times 1, the answer is 3. So this will be now your final answer, which is 2x minus 6 over 3x plus 3. If you want to write your answer in factored form, it's okay. Next, let us have now the fourth example. So 1 over x minus 1 times 1 minus x over 5. So as you can see here, okay, looking at the binomial x minus 1 and 1 minus x, there is a common factor. So to factor out 1 minus x, it is also the same as we write that 1 as negative x plus 1. So I just simply interchange these two. And then after that, we're going to factor it out. We're going to factor out negative. Okay, so as we factor out negative, okay, this will be now negative times the quantity of x minus 1. Or simply, we divide negative 1 to the expression, okay, which is the common monomial factor. So that will be negative x divided by negative 1. You'll have positive x. And then positive 1 divided by negative 1 will have negative 1. So as you can see here, we can now cancel a common factor, which is x minus 1. So as we cancel x minus 1, the remaining is, again, we have here 1 here. So therefore, the final answer will be 1 times negative 1 will have negative 1, and then 1 times 3, we have 3. You can have this as your final answer, or the other way on writing negative 1 over 3 is negative 1/3. So writing the negative beside the fraction bar. So 1/3, negative 1/3 will be the final answer. Next, let us go now to the fifth example. So we have 3x minus 9 over 3x minus 1 times 3x plus 1 over 3 minus x. So as we answer this one, so again, we need to factor first the polynomials like 3x minus 9. So there is a common monomial factor which is 3. So we have to factor out 3. So as we factor out 3, so 3 times x minus 3. So where did we get x minus 3? By simply dividing 3x minus 9 by 3. So this will be the factored form. Over, just copy 3x minus 1 because 3x minus 1 is not anymore factorable. Times 3x plus 1, just copy because it's already prime. Over, as you notice this one, I factored out negative. So as you factor out negative, that will be negative times the quantity of x minus 3. I do that one so that we can cancel a common factor, which is x minus 3. And then multiply, after that, multiply numerator to numerator, which is 3 times. Don't forget to put quantity because 3x plus 1 is a binomial. And then, on our denominator, we'll have negative 1 times the quantity of 3x minus 1. So, to get your final answer, just simply multiply each monomial to the binomial. So, that will be now 3 times 3x will have 9x, and then 3 times 1 will have 3, over negative 1 times 3x, that is negative 3x, and then negative 1 times negative 1 will have positive 1. So this will be our final answer. Next, okay, we're done with multiplication of RAE. So the next one will be the division of rational algebra expressions. And here are the steps. So dividing RAE is just the same as we divide two fractions. So the first step will be writing the equivalent multiplication statement using the reciprocal of the divisor or getting the reciprocal of the second fraction. And then after that, write each numerator and denominator in factored form. And then cancel out the common factor, multiply the remaining factors, and simplify if possible. So almost the same with multiplication of rational algebra expression. But don't forget the first step, which is to get the reciprocal of the second fraction and then proceed to multiplication of the given expressions. So now, let us proceed to our first example. So we have 2x over 3 divided by 3x over 5. So again, the first step is to write this one, the equivalent fraction, in multiplication statement. So just copy the first fraction, which is 2x over 3, and then this division sign will become now multiplication, and then getting the reciprocal of the second fraction by interchanging the numerator and denominator. So we'll have 5 over 3x. And then after that, cancel the common factors. So the only thing that we can cancel here is just x. And then after that, we have to multiply the remaining factors. So we have 2 times 5. The answer here is 10. And then 3 times 3 will have 9. So this will be the final answer, 10 over 9. So it's okay if your final answer is in improper fraction. No need for you to put it in mixed number or in decimal. So 10 over 9 will do, or can be your final answer. Next, let us proceed to the second example. We have x minus 1 over 3 divided by x minus 1 over x plus 1. So again, write the equivalent multiplication statement. So that will be x minus 1 over 3 times the reciprocal of the second fraction, which is x plus 1 over x minus 1. So we can cancel x minus 1 as the common factor, and then the remaining will just be x plus 1 over 3, and that will be your final. Okay, for the third example, we have x squared minus 4x plus 3 over 5 divided by x minus 3 over 2. So what are we going to do is to get the equivalent multiplication statement, which is x squared minus 4x plus 3 over 5 times 2 over x minus 3. So as you can see, the first numerator is a quadratic trinomial. So we have to recall factoring quadratic trinomial where a is equal to 1. So you have to think of two numbers that when you multiply, the answer is positive 3, but when you add, the answer is negative 4. And the factors are x minus 3 and x minus 1. And then just copy 5 and 2 and x minus 3 because they are all prime. And then after that, we have to cancel the common factor, which is x minus 3, and then multiply the remaining factors. So we have 2 times x minus 1 will have 2x minus 2, and 5 times 1 will just have 5. So this will be our final answer. Next, for the fourth example, x squared minus 2x minus 3 over x minus 3 divided by x squared plus 3x plus 2 over 5. So again, your first step is to write this one, the equivalent multiplication statement, and getting the reciprocal of the second fractions, which is x squared minus 2x minus 3 over x minus 3 times x plus 2 over x squared plus 3x plus 2. Okay, and then after, or the next step is to get the factored form of the given expressions that can be factored. So x squared minus 2x minus 3, the factors are x minus 3 and x plus 1. So just copy x minus 3 times copy x plus 2, and then we need to factor x squared plus 3x plus 2, which is x plus 2 and x plus 1. And then after we write the following expressions in factored form, the next one is to cancel the common factors. So the first common factor here is x minus 3. And we can also cancel x plus 1, and we can also cancel x plus 2. So as you can see, all of the expressions have been cancelled out. So therefore, the final answer is not 0, but rather again 1, because we divide or we multiply the same, we divide the same expression by another expression, okay, or same expression. So that will just be 1, okay. And for the last example, we have here x squared minus 1 divided by x cubed minus 1. So again, write this one in equivalent multiplication statement and getting the reciprocal of the second fraction. So just copy x squared minus 1 times, again, 1 over x cubed minus 1. So why is it 1 over x cubed minus 1? Because again, any polynomial expressions, their denominator is 1. So therefore, as we interchange, that will be now 1 over x cubed minus 1. So x squared minus 1, we can still factor this one using factoring difference of two squares. So that will be x plus 1 times x minus 1 times 1, just copy 1, over x cubed minus 1 is, we can use here factoring sum or difference of two cubes. So getting the cube root of x cubed, which is x, minus the cube root of 1, which is 1. And then square the first term, so that will be x squared. And then plus x, multiplying x and 1. And then square the last term will just be 1. And then after that, we need to cancel the common factor, which is x minus 1. And then we need to multiply the remaining factors. So that will be x plus 1 times 1. We'll just have x plus 1 all over x squared plus 1 plus x plus 1. So that will be our final answer. Again, do not cancel 1, do not cancel x. So that's all. Thank you for watching. See you again on our next synchronous session. Thank you.